Let's take a trip back in time, way back, 300 million years to be exact. Imagine an alien planet, but it's not in some distant galaxy, it's right here on Earth. A world covered in bizarre, towering forests and stocked by insects the size of birds. This unbelievable lost world left something behind, a black rock that, believe it or not, powers our lives today.
It's kind of crazy when you think about it. Our entire modern world, it was built on this black rock, a strange inheritance from a time we've all but forgotten. So, to really get the story behind coal, we have to become time travelers. We have to go back and visit the spectacular and, frankly, very strange world that created it.
So, what do we call this era? This is the Carboniferous period. The name literally comes from Latin. Carbo means coal, and ferro means to bear or to carry. So it's the coal-bearing age. And this wasn't just some brief moment. We're talking about a 60 million year-long chapter in Earth's story that completely revolutionized the planet.
Okay, so if we want to understand where coal comes from, we have to start with our first clue, the raw material itself. But I need you to forget everything you think you know about forests, because this was something else entirely. Something far, far stranger. Yeah, you're not going to find any oak or pine trees here. No way. The kings of this forest were plants like Lepidodendron, the scale tree. Now, these weren't actually trees in the way we think of them. They were gigantic relatives of today's tiny little club mosses. You know, that little plant you might step over on a hike? Well, back then, they were scaled up to an incredible size, creating these vast, misty swamps that just stretched on forever.
I mean, some of these giants grew up to 40 meters tall. That's like a 13-story building. And their trunks weren't even solid wood. They were hollow, supported by this thick, tough bark with a pattern that looked just like reptile scales. They had this live fast, die young kind of life cycle. They grew incredibly fast, and when they died, they toppled over into the swamps, creating just a staggering amount of raw organic material.
But here's the thing, these forests weren't just growing, they were acting like a giant air conditioner for the entire planet. Through photosynthesis, they were breathing in huge amounts of carbon dioxide and pumping out tons and tons of oxygen. They were literally re-engineering the air itself. And that brings us to our next absolutely wild clue.
All of that extra oxygen getting pumped into the atmosphere, it had a truly mind-blowing side effect. It created a supercharged, high-oxygen world that allowed life, especially insects and other arthropods, to just shatter all the modern rules of size.
Up in the sky, you have to remember, there were no birds yet, no pterosaurs. So who ruled the air? Well, meet Meganora. Think of a dragonfly, but with a wingspan of 70 centimeters. That's the size of a modern hawk. They were the absolute kings of the Carboniferous sky, and there was nothing up there that could touch them. And if you were brave enough to look down on the forest floor, you might see this crawling past, Arthropleura. This was a relative of today's millipedes that grew up to 2.5 meters long. That's longer than a king-sized bed. Covered in armor plating, it was basically an invincible tank, the biggest land invertebrate in the entire history of Earth, period.
So you have to be asking yourself, how is this even possible? A bug that big today it wouldn't work. Its body couldn't support it. So what was the secret ingredient? What was the cheat code that allowed the Carboniferous to become this land of giants? Well, the answer was literally in the air they breathed. See, our atmosphere today is about 21% oxygen. Back then, it peaked at nearly 35%. Think of it like this. Today's air is regular fuel. Carboniferous air was high-octane rocket fuel. It supercharged the simple breathing systems of insects, letting them get enough oxygen to power bodies far, far larger than what's possible today. Okay, so we've got the fuel, these massive forests, and we've got the bizarre, high-oxygen world they created. But there's a key part of the puzzle missing. For all that wood to become coal, it couldn't just rot away like a log does today. And the final clue lies with the planet itself, which set the perfect trap. The Earth itself was going through some major changes. Continents were literally smashing into each other, forming the famous supercontinent Pangaea. This massive collision created these huge, sinking basins right near the equator, which then flooded over and over again as sea levels rose and fell with the distant ice ages. It created the absolute perfect conditions for preserving a forest. What you had was the perfect recipe. When those giant trees died, they fell into stagnant, swampy water that had very little oxygen. The water was acidic, which meant the normal bacteria and fungi that cause rot just couldn't survive.
So as the land slowly sank, new forests grew on top of the old ones, burying them layer after layer. It effectively pickled the wood for millions of years. And this process just repeated over and over for millennia. These layers of pickled wood built up into thick deposits of what we call peat. As they got buried deeper and deeper, the incredible heat and pressure from the earth squeezed out all the water and cooked that peat into the dense, carbon-rich rock that we know as coal.
And when you really stop and think about it, that's just amazing. Every single lump of coal is a time capsule. It's a battery that was charged with sunlight. Not yesterday's sunlight, but sunlight that fell on an alien world, captured by those bizarre scale trees, and then stored underground for 300 million years.
But you know how it goes. All good things must come to an end. This unique world, this paradise for giant plants and giant insects, it couldn't last forever, and its end was just as dramatic as its existence.
About 305 million years ago, the climate suddenly changed. It got a whole lot cooler and drier across the globe. This triggered what scientists call the Carboniferous rainforest collapse. Those vast, continent-spanning swamps dried up and broke apart into little islands of forest. For the animals that depended on that wet world, it was an absolute catastrophe.
But you know, every crisis creates an opportunity. The giant amphibians, who needed water for their eggs, were in big trouble. But another group was ready and waiting in the wings, the reptiles. Their tough, scaly skin was a good start, but their secret weapon was the amniotic egg. It was basically a self-contained pond, a private little ocean for their developing young, which meant they could finally break free from the water and conquer the new, drier world. So when we look back, the legacy of the Carboniferous is just immense. It gave us the coal that literally fueled the Industrial Revolution. It supercharged our atmosphere with oxygen. It created the rich soils we depend on. And yeah, it cleared the way for the age of reptiles and eventually the dinosaurs. It really did shape the world we live in today.
And this is where the story really connects to our world today. The whole story of the Carboniferous was about taking carbon out of the atmosphere and burying it underground. It was a massive act of carbon fixation that ultimately cooled the entire planet. And what are we doing in the modern era? The exact opposite. We're running that 300-million-year-old process in reverse at hyperspeed.
Which leaves us with one last, pretty big thought to chew on. The very same geological process that gave us these black diamonds to build our civilization was also the process that acted like a global thermostat, cooling the planet down. By digging up that ancient world and burning it, we're now cranking that thermostat back up.
And that is our quick look into the Carboniferous. I mean, what an absolutely epic time in Earth's history, right? The story of this forgotten world, its giant forests and monstrous creatures, is so huge that what we've been able to share with you here, honestly, it's just a prologue. For a much deeper dive into this lost world and its incredible legacy, be sure to check out the complete version of this explainer.
Hey everyone, and welcome. Today, we are going to travel back in time, about 400 million years, to one of the most game-changing periods in Earth's history, the Devonian. This was an era that completely reshaped our planet. You had oceans just teeming with incredible new fish, the very first forests were reaching for the sky, and yeah, our own distant ancestors were taking their first wobbly steps out of the water.
So, to really explore this amazing time, we're doing a 10-question challenge. I'll throw a question your way, you take a second to think about it, and then I'll reveal the answer with some pretty fascinating details from the latest science. So grab a pen, keep score, and let's see if you can nail a perfect 10. You ready? Let's do this. All right, question 1. Let's ease into it with a classic. The Devonian is probably most famous for one particular group of animals that just had this incredible evolutionary explosion, basically taking over the entire marine world. So what do we call it? And the answer is the Age of Fishes. And you know, this title is so perfect, not just because there were a lot of fish, but because they evolved two absolute game changers, jaws and paired fins. Suddenly, they were faster, more agile, and way more effective hunters. They became the undisputed rulers of the sea.
Speaking of rulers, let's talk about the apex predator's apex predator, the terrifying Dunkleosteus. For decades, we all had this image of a long, slender, armored beast. But some brand new research has completely torn up that picture. So how has our view of this giant changed?
Well, the difference is just staggering. We used to think Dunkleosteus was this huge, 10-meter-long, shark-like creature. Turns out it was actually much shorter, about 4.1 meters max, and it was built like a heavyweight boxer. Think less like a shark and more like a giant armored tuna,
super muscular and powerful. This completely changes its lifestyle, from a slow ambush predator to an active, terrifying hunter out in the open ocean.
Okay, let's head on to land. Before there were trees, the landscape was dotted with these bizarre 8-meter-tall towers. Seriously, just imagine that. For years, scientists debated what these things, called prototaxites, could possibly be. Giant fungus? Some weird plant? Well, brand new research from 2025 has thrown a massive curveball into this debate. So what did they discover?
Get ready for this, because the answer is truly mind-bending. It wasn't a plant, and it wasn't a fungus. Prototaxites appears to be from a completely separate, totally extinct kingdom of life. Chemical analysis found none of the chitin you'd expect in a fungus. It suggests a third kingdom of complex life existed on Earth and has been completely lost to time. How wild is that?
All right, so now let's talk about the plants that did create the world we recognize. In the late Devonian, one particular plant showed up that really changed everything. It had all the features of what we'd call a modern tree, and it had one key trick up its sleeve that let it conquer the continents. What was it called?
The answer is Archaeopteris. It was kind of a strange hybrid. It had fern-like leaves, but a big, strong, woody trunk that could shoot up 30 meters into the sky. But the real revolution was happening underground. It developed the very first deep, powerful root system. This allowed it to anchor itself and suck up water from deep within the soil, which meant for the first time, life could move away from the coasts and swamps. This single adaptation literally unlocked the continents.
But here's the twist. The incredible success of Archaeopteris came with a very dark side. There's a theory called the Devonian plant hypothesis, which argues that this green revolution on land actually triggered a global catastrophe. What was this two-part crisis?
It was a truly devastating chain reaction. First, those powerful roots started breaking down rocks, which flooded the rivers and oceans with mineral nutrients. This caused enormous algae blooms that, when they died and decayed, sucked all the oxygen out of the water, creating these huge, dead zones. At the exact same time, all that new plant life was pulling massive amounts of CO2 out of the atmosphere, which crashed the planet's greenhouse effect and plunged the world into an ice age. Life itself had changed the climate.
So while the oceans were in total crisis, life on land was just getting started. And there's this one fossil site in Scotland that gives us an unbelievably perfect snapshot of the world's first land ecosystem. What do we call this incredible 400-million-year-old time capsule?
That would be the one and only Rhynie Chert. This place is one of the most important fossil sites on the entire planet. Basically, a hot spring erupted and flash fossilized a whole ecosystem. The preservation is so perfect, we can see the internal organs of tiny little creatures. That's how we found Paleocharinus, a spider-like animal with its book lungs perfectly preserved, definitive proof that it was breathing air.
Okay, now for the main event. Vertebrates finally making their move out of the water. Back in 2004, paleontologists found this incredible fossil that is pretty much the perfect missing link between fish and land animals. What is the name of this famous fishapod?
Of course, it's the amazing Tiktaalik. This fossil is just a beautiful snapshot of evolution in action. It's got fishy scales and fins, sure, but it also had these new features for life in the shallows. It had a neck, so it could turn its head to snap at prey without moving its whole body. It had sturdy little wrist-like bones in its fins, so it could do push-ups on the muddy bottom, and it had strong ribs to support its body out of the water. Okay, so this story gets even weirder. The first four-limbed animals, or tetrapods, like a conostega, they had feet. But they had feet with 8 toes. So what does this bizarre anatomy tell us about why feet evolved in the first place? I mean, was it for walking?
And the surprising answer is, nope, not for walking. The limbs on these first tetrapods were actually really weak and paddle-like. There's no way they could have supported their weight on land. Instead, they were used in the water, probably to help them move through dense, swampy underwater vegetation. It's a perfect example of what scientists call pre-adaptation. A feature evolves for one reason and then later gets used for something totally different. Feet were for swimming long before they were for walking.
Now, the Devonian story played out all over the globe. While Japan as a country didn't exist yet, the land that would eventually form it was part of a much larger continent, and a key fossil found in Iwate Prefecture gives us proof that these ancient lands were covered in forests. What is that fossil?
The answer is the fossilized bark of a tree-like club moss called Leptofloavium rhombicum. And this is a huge find. It's direct proof that large wetland forests existed there. And what's even cooler is that scientists have found the exact same species in places like China and Australia. This helps them piece together the puzzle of how these landmasses were all connected as part of the ancient supercontinent Gondwana.
Okay, it's time for our final question, and this one comes from the world of pop culture. In the fantastic Studio Ghibli movie Ponyo, the whole town gets submerged in water, and these ancient sea creatures from the past appear. Which accurately drawn, boxy-looking armored fish from the Devonian do Ponyo and Sosuke meet?
That would be Bothrialepis, and you gotta give it to the animators, they absolutely nailed it. That unique box-shaped fish is unmistakable. And the choice to include it was just genius. Think about it. The Devonian was this age of transition, when life was blurring the line between the sea and the land. It perfectly mirrors the movie's own themes of transformation, as Ponyo, a sea creature, wants to cross that boundary and become human.
And that's all 10. So tell me, how'd you do? Did you get a perfect score? Were you a Devonian master? Hey, whether you got one right or all 10, I really hope this has shown you just how incredible and important this ancient world really was.
Because the Devonian isn't just some lost world of weird monsters. Its legacy is literally all around us and inside of us. The jaw you use to speak and eat, the lungs you're breathing with right now, even the basic blueprint of the bones in your arms and legs, that was all pioneered back in the Devonian. The oil and gas that power our world, much of it formed in those ancient oceanic dead zones. And of course, it's a powerful and humbling reminder of how life itself can dramatically and catastrophically change a planet's climate.
When you boil it all down, we're all a part of this incredible story. The events that unfolded in that distant, alien world set the stage for everything that came after, including us. In the most literal sense, we are all descendants of Devonian fish, a living, breathing legacy of 400 million years of life on Earth. Thanks so much for joining me.